Hello everyone and welcome to this tutorial in which we are going to discuss the basics of JavaScript syntax. If you followed the last video, you saw that we discussed this basic hello world code. If we run this, you will see this hello world output in the console. If you want to erase these outputs in the console, you can click on reset anytime. Like most other programming languages, JavaScript also has the similar basics, like there are some data types, loops, functions, conditions, operators, etc. We will begin with JavaScript data types, which include strings, dictionaries, etc. String is a sequence of characters either declared as a literal constant or in a variable. For example, here we have an example of a string. We stored this string called Google Earth Engine in a variable called textString. Variables are declared with a preceding var or variable. And what you need to store in the variable will go after the equal sign, and the line will be closed by a semicolon. To print the contents of the variable, you need a print statement with the name of the variable within the brackets. If we run this, you see Google Earth Engine being printed here. This is a result of the line number 14. You see the lines with these slashes are not printed in the console output. Why is that so? In most programming languages, we have this concept of comments which are used to make your code more readable. In JavaScript, line comments begin with a double slash. These commented lines are not executed in the final code but are there for own readability. Moreover, there are different objects, properties, and built-in methods to these variables that we declare. One such property is length, which will result in the length of the string. For example, if we write print and then enclose this property within the brackets and run this code, you see we get 20, which is the length of the string. Similarly, we have different methods like the one here. Let's see what happens. You see, as the method was converting to uppercase, it is a built-in method that we can run on our own string. Here, it has converted the whole string to uppercase. And by the way, here you can see single quotes, but we can also use double quotes here. If we convert those to double quotes and run, you see nothing changes. Next, we can also store numbers in those variables. For example, here we had a variable called number and we stored 99 in it. Here you can see the output of this statement. What we did was we stored it in the variable. Then we wrote which the console is going to print my number is in quotations because it will be printed as it is in the console, and number after a comma. Anything previously stored in the variable called number will be printed here. As you can see it here, my number is. Next up, we have list in which we can store any collection, series, or sequence of numbers or strings. As you can see here, we declared a list called myList and stored this list of numbers in it. Then we printed it using this command, and you can see that result here. You can see the JavaScript index begins with 0 and we have the number 0 on index 0. Similarly, the list of index goes up to 5 and so the numbers. Coming down, we have another list of strings, and we stored x, y, z, or we can write anything else here. For example, we currently have x, y, and z here that are printed here. If we write anything else here like ABC and run, you will see the output has changed here. And as you can see, lists are stored in square brackets. Another very important data structure within JavaScript and many other programming languages is object. Objects in JavaScript are dictionaries of key and value pairs which are denoted using curly brackets as you can see here. In this example, we declared an object called myObject and stored three keys in it, namely ABY, Nota, and item. Then we stored different values to those keys, which are mentioned here. As you can see, we stored that whole list within a key which contains values, namely county, zone, and country. We printed this object using this statement, the result of which we can see here. This is the dictionary object printed here with these different keys value pairs. Moreover, we can access the different items within these objects using square brackets or the dot object notation. In the first example, we access the first key of this object using this square bracket notation from this object. The result of it we can see printed here. In the second example, we use the dot item notation to extract the values of this key called item from this object called myObject. The result of it is displayed here. Let's move on from data structures and look at functions. Functions are another way to improve the readability and reusability of our code by grouping different sets of similar operations within one function. Function in JavaScript is called using the keyword called function, which is then followed by the name of the function which comes within the parentheses. The contents of the function or the statements to be executed by the function are written within these curly brackets. Everything within the curly brackets is a part of the function and is executed when the function is called. Here is an example of a very simple function called element in which the element will be passed and then returned to the function. The returned element will be stored within the variable called test, and whenever we print the variable called test, the element that was passed within the function will be printed. Now let's look at a near real-world example of a function. Here we have a function that we call calculator. In this function, we pass two parameters called a and b. The contents of this function are within these curly brackets. There are four different statements in which, first of all, a and b are added, then subtracted, divided, and multiplied. We close the function and we call the function using this statement here. We use the name of the function to call it, and then we pass different values to these a and b. We pass 3 to a and 4 to b. Then these values are subsequently passed through all the different lines of this function in which we have a and b in these lines. If we run it, you see a and b is added, subtracted, divided, and multiplied respectively. Moving on from functions, we have compound assignment operators. This is a very simple code in which a variable called x is declared, and then we say that We want to update x after adding 1 to the value of x. Then we print x and get 4 as a resultant because 1 was added to the initial value of x, which was 3, hence resulting in 4. This line here, which I am highlighting, can also be written in a simplified way, which is called a compound assignment operator. This is done like this. For example, we have x and we say that update the value of x after 1 is added to the initial value of x. X plus equal to 1 is same as writing x is equal to x plus 1, and the result is same. Now let's look at conditional statements. If and else are one popular type of conditional statements. Conditions in computing mean that the program will check if a given condition is true, then the program will print or perform a certain action, and if the condition is false, the program will either terminate or perform something else. In this example, we declare the age of a person to be 20, and then we write a conditional statement, an if statement, that if the age is above 18 in any case, then the computer will print that the person qualifies for driving. Let's run it. You see, because the actual age of the person was 20, but the condition is that the person only needs to be above 18, so because he is actually above 18, so he qualifies for driving, and the computer prints us so. Now what if we also want to tell the computer what to do if the condition is not met? Then we use the else statement in conjunction with the if statement. Let's look at an example. For example, the actual age of the person is 15 here, and here we have the statement just like above, that if it is above 18, the person is qualified for driving. But what else? What if the age of the person is less than 18? See, the condition will not be fulfilled here. So what does the computer do? It moves on to the else statement and prints does not qualify for driving. We have that here, does not qualify for driving. Why? Because the age of the person is actually less than 18 and the condition is not met, so the program moves on to the else statement. Here you can also use other operators. For example, if we have a condition in which two numbers are to be equated or checked if they are equal, we use double equal to sign here like this. There are many other operators like equal or greater than that we can use in these conditions. Interestingly, these conditional statements can be written in a simplified way using a conditional operator called a ternary operator. This simplifies the code to one line. For example, we have a code which checks if the person is eligible to vote. We declare a variable in which the result will be stored. We name the condition called votable and we check what is stored in it. For example, we already have the age as 15 and we check if the age is less than 18 or greater than 18. Our initial condition is that if the age is 18, the computer will print that the person is too young. And if the condition is not met, which means that the age is greater than 18, then the computer will print us that the person is old enough to vote. Let's run it. You see, our last variable declaration for the variable age was 15, which means that the age of the person is 15, and because 15 is less than 18, the person is too young for voting. If we change it to 20 here, You see, the computer prints us old enough for us because now the age is 20 and the person is greater than 18, which means that he can actually vote. Now let us look at logical operators. These are used when we want to check the truthness or falseness of a compound statement. In this example, 6 is stored in x, 3 is stored in y, and we want to check if x is less than 10 and y is greater than 1. Which is true, both these statements are true, and we have this AND operator in between which wants to check if both these statements are true. And we have seen that both the statements or conditions are fulfilled. If we run it, you see true is printed here. That's what we wanted. In the second compound statement, the first part is true, but let's look at the second part. We want the y to be less than 1, but that is not true because y, as it was declared, is greater than 1. It is actually 3. So this part of the compound statement is not true. So the whole statement is not fulfilled. The condition becomes false, and that is what's printed here. Moreover, we can also use the OR statement. Now if we run it, you will see that both statements will become true. See, that is because the condition for the OR operator is that just one of the statements or conditions need to be true. And we have one of them true, the second one is false, but that does not matter because even if one is true, the OR operator will result in a true. Now, if we want to flip the result, you can use the NOR operator, which can be declared using a exclamatory mark. If we run it, you will see the result to be flipped and it becomes false. Now let us look at the last part of our coding exercise, which is on loops. In computer programming, a loop is a sequence of instructions that is continually repeated until a certain condition is reached. There are different types of loops in JavaScript, which are for loop, for in loop, while loop, and do while loop. However, we will only look into for loop here, and I want you to practice the rest of them on your own. For loop is the most compact form of looping, and it concludes the following three parts, which we will discuss. So here we have a very basic print statement for our own understanding that we are going to start the loop structure. The loop structure starts here with the for keyword, and within the parenthesis, there are three parts. Number one, loop initialization, which is here. In the loop initialization, we initialize our counter to a starting value. The initialization statement is executed before the loop begins. Here, the initial value is 0 and it is stored in a variable which is I here. It can be anything else too. Then, the test statement, which will test if a given condition is true or not. If the condition is true, then the code given inside the loop will be executed. Otherwise, the control will come out of the loop. Here, the condition is that the code will run as long as I is less than 10. Then we have the iteration statement where you can increase or decrease your counter, which means that the counter will start at 0 and it will increment and the code will run within the for loop as long as the value of I is less than 10. So within the loop, we print that the count and this print statement will run multiple times depending on the initial condition and the final condition, and it will be incremented one by one. For example, if we run it, we see in the first iteration, it says that the current count is 0 because our initial condition or statement is 0. Then it goes to 9 because our final statement or test statement was that I needs to be less than 0 and the code will break if I reaches 10. So it reaches up till 9 and then breaks. Then we have this statement that the loop has stopped. Here, nothing special is happening. This is for our own understanding. And this means that we will print I after every iteration, which means after every iteration, the newly stored value of I will be printed here. So this lecture covered the basics of JavaScript syntax. We will use all these basics in our future lectures for geospatial processing within the Google Earth Engine code platform. Thank you, and that's all for today. Please subscribe to our channel and give us feedback upon what we have seen until now.